Okay, in this video, we're going to be looking at how to test a claim about a proportion. Okay, so here we're going to be applying some of the techniques or some of the things that we talked about in the last video that has something to do with the basic concepts of hypothesis testing to test a claim about a proportion, and then for a mean, and then for a standard deviation. But in this video, we'll just deal with the proportion. Okay, now there are three requirements for testing a claim about a proportion. One of them is this: you must have a simple random sample, and that means that each sample of a certain size has an equal chance of being selected. And then number two, you must have your conditions for a binomial distribution. They have to be satisfied as well. In other words, what do I mean by that? That means that you must have a fixed number of independent trials that have constant probabilities, and each trial has two outcomes, either success or failure. And then the sample size times the probability of success is greater than or equal to 5, and n times the probability of failure, which is your Q, has to be greater than or equal to 5. So those requirements must be met in order to test a claim about a proportion. And once that's met, we can apply the test statistic for a proportion. And the test statistic, by the way, is this formula. Z is equal to p hat minus p, and all that's divided by the square root of pq divided by n, and that pq divided by n is all underneath the radical. Now, what do these variables mean? In this case, p hat is your sample proportion, where p hat is always x over n. In some cases, you're not given the p hat directly, because you might be given the number of successes and the sample size. So to calculate p hat, you use x divided by n. And then the value from your null hypothesis, that's going to be your p. And then q, once you know what p is, that's simply 1 minus p. And then n is just simply the sample size. Okay. Now, let's look at some examples of just this. And I'll start off with some examples that have the data display in it, and we'll go into the ones where we have to use that 8-step procedure. Alright, in this example, we have a certain drug that's used to treat asthma. In a clinical trial of the drug, 21 of 290 treated subjects experienced headaches based on data from the manufacturer. The accompanying calculator data display shows results from a test of the claim that less than 9% of the treated subjects experienced headaches. Use the normal distribution as an approximation to the binomial distribution and assume a 0.01 significance level to complete parts A through E below. So in part A, you want to find out, is the test two-tailed, left-tailed, or right-tailed? And by looking at this, so here's the calculator display on the right-hand side. By looking at this, I can see that the proportion is less than 0.09. Well, less than means that it's shaded to the left. Your critical region is shaded to the left, so that's going to be a left-tail test. And then part B, what is the test statistic? Your Z value is your test statistic. Now, I know this is probably going to be hard for you to see, but your test statistic in this case is negative 1.046475888. But to two decimal places, we're going to round it off to negative 1.05. So your test statistic is negative 1.05. And then they want the p-value. Lowercase p is your p-value. Do not get that confused with p hat. P hat is your sample proportion. Lowercase p is the p-value that you want. In this case, it says 0.1476706,858, but to 4 decimal places, we're going to round it out to 0.1477. So your p-value here is 0.1477. Okay, and then part D, what is the null hypothesis? Well, if our alternative hypothesis, where the proportion is less than 0.09, the null had to be p is equal to 0.09, because the null always has the equality in it. Always has the equal sign in the null hypothesis. And what can we conclude about it? Well, here's our conclusion statement, or decision rule. If your p-value is less than or equal to alpha, you're going to reject the null. So in this case here, your p-value was 0.1477 from part C. Your alpha level was given to you as 0.01. So if we compare 0.1477 with 0.01, 0.1477 is greater than 0.01, which does not satisfy the decision rule. So that means we have to fail to reject the null hypothesis. Okay, so we failed to reject the null because 0.1477 is not less than or equal to 0.01, which is our alpha level. So next is the final conclusion, and we have to use simple, non-technical terms. So if you recall this handout of wording the final conclusion, in this case here, the claim was the alternative hypothesis, but we failed to reject the null. So we say that there is not sufficient evidence to support the claim. So in this case, we say in our conclusion that there is not sufficient evidence to support the claim that less than 9% of treated subjects experience headaches. Okay? So that's how we write our conclusion here. Okay, next example. Let's say we had a survey of 1,681 randomly selected adults show that 539 of them have heard of a new electronic reader. The accompanying technology display results from a test of the claim that 36% of adults have heard of the new electronic reader. Use the normal distribution as an approximation to the binomial distribution and assume a 0.05 significance level to complete parts A through E below. So here's the output that we got, and part A states, is the test two-tailed, left-tailed, or right-tailed? Okay, here in this case, my critical Z value, I got plus or minus 0.196. That tells me that there are two critical values, which means if there are two critical values, the test is a two-tailed test. And then part B is, what is the test statistic? Well, that's given to us in the problem. That's your Z value. That's your test statistic. In this case, to 2 decimal places, it'll be negative 3.36. So your test statistic is negative 3.36. Then part C, what is the p-value? Well, here's your p-value right here. That's also given to us. That's 0.0008. Okay? So pretty much A, B, and C are already given to us in the problem. Part D, what is the null hypothesis and what do you conclude about it? In this case here, the null hypothesis, it states that 36% of adults have heard of the new electronic reader. So it has to be equal to, because it doesn't say greater than or less than or more than or at least, or doesn't give much of a directional language. So your null hypothesis has to be this, P is equal to 0.36, and that's also the claim. Okay? And then our conclusion to fail to reject or reject the null is this. If your p-value is less than or equal to alpha, you're going to reject the null. Here the p-value was 0.0008 and the alpha level was 0.05. So here 0.0008 is less than 0.05, so in this case we reject the null. And then our final conclusion, here's the final conclusion, that there is sufficient evidence to reject the claim that 36% of adults have heard of the new electronic reader. Okay. So in those two examples, we were given calculator handouts or software displays to help us reach conclusions. Now these next examples, we're going to be applying that hypothesis testing procedure, and that's this sheet that's on Cruiser. Now we'll be following this particular procedure in order to reach our do our hypothesis testing and reach our conclusion. Okay, and this is also on Campus Cruiser for those of you who are taking my online course. Okay, so now let's look at this example. A genetics experiment involving peas yielded one sample of offspring consisting of 408 green peas and 122 yellow peas. Use a 0.05 significance level to test the claim that, under the same circumstances, 27% of offspring peas will be yellow. Identify the null hypothesis, alternative hypothesis, test statistic p-value, conclusion about the null hypothesis, and final conclusion that addresses the original claim. Use the p-value method and the normal distribution as an approximation to the binomial distribution. So in this case, we're going to be applying the p-value method with this 8-step procedure. So here's how the 8-step procedure works. First of all, we got step number 1. And step number 1 is stating the original claim in symbolic form. And by looking at this, 27% of offspring peas will be yellow. Okay? Doesn't say less than or greater than. So that means we have to say P is equal to 0.27. Now keep in mind we're testing a claim about a proportion and we're given percents. So we have to use P is equal. We use P as our population proportion. And 27% as a decimal will be 0.27. And then step number 2, we write the opposite of the original claim. Well, if P is equal to 0.27, the opposite of equal to will have to be not equal to. So P is not equal to 0.27. Okay. And then the third step, we're going to use step 2, or step 1 and step 2, to write the null and the alternative hypothesis. That's H sub 0 and H sub 1. Keep in mind your null hypothesis either has less than or greater than or not equal to. So the opposite of the original claim has to be your alternative hypothesis. So P is not equal to 0.27. And the P equal 0.27 must be your null hypothesis, because the null always has the equal sign, and that null hypothesis is your claim, because the original claim says P is equal to 0.27. Okay, that's step 3. Step number 4. We need to state the level of significance, which is your alpha level. Now going back to the problem, it says use a 0.05 significance level. So alpha is equal to 0.05. So that's step number 4 right there, alone. Okay. Now step number 5, I'll do step number 5 right here, is calculating the test statistic. Okay, so let's gather our sample data here. Your N is going to be this. You got 408 green peas and 122 yellow peas. So if you add 408 to 122, your sample size N is 530. And X, which is the number of successes, we're dealing with the offspring peas will be yellow, so they're 122 yellow peas. So that's our X, which is the number of successes. That's 122. Which means P hat is going to be X over N, or 122 divided by 530, which will give me, well, we'll just leave 122 over 530 as a fraction, and you'll see why. And then your P, that's from the null hypothesis, which is 0.27, and Q will be 1 minus P. That's 0.73. And that 0.73 came from the 1 minus 0.27. Q is always 1 minus P. So in this case here, we use that formula, that test statistic for a population proportion, which is Z is equal to P hat minus P divided by the square root of P times Q over N. And in this case here, P hat was 122 over 530 minus P, which is 0.27. That's divided by the square root of P, again that's 0.27, times Q, that's 0.73. All that's over N, which is 530. And all of this is underneath the radical. So to get Z, this is where we type this into the calculator. This goes in parentheses in the numerator, so I'm putting that in parentheses. So left parentheses, 122 divided by 530, close parentheses, no, minus 0.27, now close the parentheses, divided by second x squared for the square root of 0.27 times 0.73 divided by 530, close my parentheses, hit enter, and you get negative 2.06. So the Z, your test statistic in this case is negative 2.06. So that's your test statistic, negative 2.06. Okay. Step number 6. Now we're using the p-value approach, so we're going to have to calculate or find the p-value. Okay? And this is where we use that standard normal distribution table, or table A-2. Okay. Now, is this a left tail test, or a right tail test, or a two-tail test? Well, by looking at your alternative hypothesis, you got not equal to, so that tells me it's a two-tail test. So when I do the p-value, that p-value, that's going to be equal to 2 times whatever that area is to the left. That's this shaded area beyond the test statistic. Okay, so now for negative 2.06, so here's negative 2.0 right here, and 0.06 is this column right here. So if I read across, and down, that would give me 0.0197. Okay? So it's going to be 2 times 0.0197, which will give me 0.0394. So this p-value right here, actually it's half the p-value, but the whole p-value you have to multiply by 2 since it's a two-tailed test. It'll be 0.0394. Okay, so that's step number 6. Now step number 7 is this, your decision rule. Since we're using a p-value approach, we decide if the p-value is less than alpha, you're going to reject the null. So in this case, my p-value was 0.0394. My alpha level was 0.05. If you compare those two, 0.0394 is less than 0.05. So my conclusion here is this. We reject the null hypothesis. So that's step number 7, rejecting the null hypothesis or failing to reject the null hypothesis. And if we reject the null, we're also rejecting the claim that 27% of offspring P's will be yellow. Okay? So there's my conclusion statement, which is step number 8. And that's this. There is sufficient evidence to, in this case, reject the claim, because the claim was the null hypothesis, and we rejected the null, that 27% of offspring P's will be yellow. Okay? And it is that long 8-step procedure that you have to use to test the claim about a population proportion. So here, you're starting off with the original claim, and then you state your opposite of the original claim, and then from those 2 steps, that's where you state the null and the alternative hypothesis. And then in that step, in step number 4, we write our level of significance, which is usually given to us in the problem. And then step number 5 may be the hardest one. It's just calculating the test statistic from that sample data that's given to us. And then use that test statistic to find out what the p-value is, which is step number 6. And it's a two-tailed test, so we had to do 2 times the area that's in that table. And it's the cumulative area to the left when you're using the standard normal distribution table. And then the 7th step would be to state your decision rule, whether to reject the null or fail to reject the null. And then write your conclusion using simple, non-technical terms. Okay, here's another example. All right, in this case, in 1997, a survey of 880 adults showed that 157 of them used email. Use those sample results to test the claim that more than 15% of households use email. And use a 0.05 significance level. Use this information to answer the following questions. Now we can use that 8-step procedure that I already went over in the last example to answer these 5 questions, parts A through E. So I'll go ahead and do that. Starting with step number 1, which is the original claim. Okay, the original claim is this. More than 15% of households use email. So it's going to be P is not equal to, is actually greater than. So using the greater than symbol for more than. Okay, so P is greater than 0.15. That's your original claim. Now step number 2 is the opposite of the original claim. Well, the opposite of greater than will have to be less than or equal to. So P is less than or equal to 0.15. That's the opposite of the original claim. Keep in mind, for greater than, its opposite is less than or equal to. And then we use steps 1 and 2 to write the null and the alternative hypothesis. Okay. Now the null always has either less than or greater than or not equal to. In this case, your original claim is going to be your alternative hypothesis. So this will be P is greater than 0.15, which is your alternative, and that's the claim. The null always has the equal sign regardless. So P is equal to 0.15. Okay? And that's the answer to part A. That's the null and the alternative hypothesis. Right, step 4 is stating the level of significance. In this problem right here, the level of significance is 0.05. That's given to us, so that's going to be your alpha level, 0.05. And then step number 5 is calculating your test statistic. Okay, we had a survey of 880 households, so that's your N, which is 880. 157 of them use email, so X is 157, which means P hat, that's X over N, which is 157 divided by 880. 157 divided by 880, and we'll leave that as a fraction. And we're told that P is equal to 0.15 from the null hypothesis, which means that Q must be 0.85. Okay? So we have all that information, that sample data, to calculate the test statistic. And that's Z is equal to P hat minus P divided by the square root of PQ divided by N. P hat in this case is that 157 over 880 minus P of 0.15 divided by the square root of P is 0.15 times Q, that's 0.85, all over N, which is 880. Oh, that's underneath the radical. And when we type this in the calculator, make sure you put your numerator in parentheses. So in this case here, let's see, left parentheses, 157 divided by 880 minus 0.15, close parentheses, divided by the second and x squared, 0.15 times 0.85 divided by 880, and to 2 decimal places, your critical Z value will be 2.36. Okay, so in this case here, your test statistic to 2 decimal places will be 2.36. So that's step number 5, calculating your test statistic. Okay, now And by the way, that's the answer to part B. What is the test statistic? So in this case here, 2.36. Now in step C, what is the p-value? So that's going to be step number 6. Finding the test statistic. Okay. Now, we look at our alternative hypothesis to determine whether it's a left tail, a right tail, or a two-tail test. The alternative says P is greater than. So in this case here, we're going to have a right tail test. So the p-value is going to be this area to the right. So it's this shaded area to the right. Okay. Now if we use, and by the way, this is 2.36 here, so we want that p-value. Now, if we use that standard normal distribution table, we're going to get the area to the left. So for the area to the right, you have to do 1 minus whatever that area is to the left. So for 2.36, here's 2.3 down here. 0.06 is this column right here. So read across and down. On the 0.06 column, you'll see is 0.9909. But 0.9909 is this area right here. We want that area right there. So the p-value is going to be 1 minus 0.9909, which is 0.0091. Okay. Now we don't do 2 times that. The reason for that is this. It is strictly a right tail test. So that's going to be the p-value right there. We only do 2 times the area when you have a two-tail test. And this is only a right tail test. So that's your p-value, which is step number 6. Alright, step number 7 is our decision rule of rejecting the null or failing to reject the null. And that's this. If your p-value is less than or equal to alpha, you're going to reject the null. And in this case here, compare 0.0091 with our alpha level of 0.05. You see that it is less than 0.05. 0.0091 is less than 0.005. So here we say we can reject the null hypothesis. And then step number 8 is write our decision rule. Now keep in mind the claim is the alternative hypothesis, we're rejecting the null. So here there is sufficient evidence to support the claim. That more than 15% of households use email. Okay, so that's that 8-step procedure here. So some of these will help to answer the question. So like in part D, what is the conclusion? You would reject the null, which is part of step 7 and 8. And then part E is the conclusion valid today. Actually, it wouldn't be valid because we're looking at something from 1997. Okay? So in this case, it might not be valid today because the population characteristics of the use of email, they're changing daily, on a daily basis. So in this case here, what might have applied in 1997 might not be the same today. Okay, got one more example, one final example, and that's this one. When testing gas pumps for accuracy, field quality enforcement specialists test pumps and found that 1,316 of them were not pumping accurately within 3.3 ounces when 5 gallons are pumped, and 5,674 pumps were accurate. Use a 0.01 level of significance to test the claim of an industry representative that less than 20% of the pumps are inaccurate. Use the p-value method and use the normal distribution as an approximation to the binomial distribution. Okay, so here we'll use that same 8-step procedure that we used in the last two examples. Starting with step number 1. And in step number 1, you state your original claim. And it says less than 20% of the pumps are inaccurate, so P is less than 0.20. That's how we write that in symbolic notation. P is less than 0.20. The proportion of gas pumps is less than 0.20. Step number 2 is the opposite. Well, the opposite of less than will have to be greater than or equal to. So that means the opposite of the claim would be P is greater than or equal to 0.20. And then from steps 1 and 2, we can write our null and alternative hypothesis. So in this case here, your null and your alternative. So in this case here, your null will always have an equal sign in it. So it's going to be P is equal to 0.20. Now the alternative always has either less than or greater than or not equal to. This one has the less than symbol. So that's your alternative hypothesis, and that's also the claim. So your alternative hypothesis will be the claim. Then step number 4 is your level of significance. In this case, we're using a 0.01 significance level, so your alpha level is 0.01. And then step number 5 is calculating the test statistic. Alright, now let's look at our sample data that we have. The N is this. You got 1,316 pumps that were not pumping accurately and 5,674 pumps that were accurate. So add 1,316 to the 5,674 and you will get 6,990. That's your sample size. Okay, so be very careful here. Now, we're dealing with less than 20% of them that are inaccurate, and 1,316 of them, of those pumps, were not pumping accurately, so that's your number of successes. Okay? Because we're testing a claim that less than 20% of the pumps are inaccurate, and 1,316 of them were inaccurate. So in this case, here, X is 1,316. So P hat would be X over N, or 1,316 divided by 6,990. And we'll leave that as a fraction as well. And in this case, P was 0.20, so Q must be 0.80. And that's 1 minus P. Okay, so now we can use our test statistic from this given information. Z is equal to P hat minus P divided by the square root of P times Q divided by N. Now in this case, your P hat is that 1316 over 6990 minus P, which was 0.20, divided by the square root of P again is 0.20 times Q, which is 0.80, divided by N, which is 6,990. Now again, we put this in the parentheses when we use the graphing calculator. And in this case here, starting with left parentheses, 1316 divided by 6990 minus 0.20, and close your parentheses, divided by second x squared for the square root, 0.20 times 0.80 divided by 6,990. Now here my test statistic is going to be negative 2.4520. Okay. And I'm rounding this off to 4 decimal places. And on the homework, be sure that you round whatever your z value is or your test statistic to whatever number of decimal places that they ask for. Sometimes they may ask for 2 decimal places, they may ask for 3, they may ask for 4. So pay close attention to the directions on how many decimal places that they ask for in the homework. Step number 6 is your test statistic. I mean, not test statistic, your p-value. Now in this case here, negative 2.4520 would be to the left of 0. And look at your alternative hypothesis, you have less than. So that tells me I'm going to have a left tail test. So the p-value will be the area that's on the left, to the left of negative 2.4520. And to 2 decimal places, I'm going to say negative 2.45. So we use the negative z-scores on the normal standard distribution table and find negative 2.4, that's up here, and 0.05 is right here. So read across and down, you'll see that it's 0.0071. So this area that's shaded in red, that's your p-value. That's 0.0071. So the p-value there will be 0.0071. And then step number 7 is your decision rule. And that's this. If you have a p-value that is less than or equal to alpha, you reject the null. If your p-value is less than alpha, you reject the null. So here your p-value is 0.0071. That alpha level is 0.01. In this case, that is less than 0.01. Your p-value is less than your level of significance, so we can say that we reject the null hypothesis. And in this case, our claim was the alternative hypothesis. We rejected the null, so that means that there is sufficient evidence to support the claim. So step number 8 is our conclusion, where there is sufficient evidence to support the claim that less than 20% of the pumps are inaccurate. Okay, that's a C right there. Okay, so that's your 8-step procedure for testing a claim about a population proportion. And I realize that this might seem a little bit time-consuming, but once you get the hang of this, once you get some practice on this, you'll be fine. And I do have additional examples that are on Cruiser that you can refer to. And those should assist you with the homework for testing the claim about a population proportion. Okay? So that will conclude this video on just testing a claim about a population proportion.